In this question, we have a golfer who hits a ball with a velocity of 30 meters per second at a 45-degree angle. And we want to know how far the ball travels and what was the ball's maximum height. Now I hope you can tell, based on the parabolic trajectory, that this is projectile motion. And that means we need to consider the x component, which is uniform motion, and the y component, which is free fall motion. Starting with the x component, we can say that the initial position, xi, was 0 meters, and we know because this is uniform motion, the acceleration for the x component is 0. Now we can also figure out the velocity for the x component, since Vx is equal to v cos theta. And let's do that here. All we have to do is plug in our values and solve for Vx. And what we find is the velocity in the x component is 21.2 meters per second. Now let's look at the y component. Yi is 0 meters because the ball starts on the ground, and Yf is also 0 meters because the ball lands on the ground. And now because this is free fall motion, the acceleration in the y component is equal to negative 9.8 meters per second squared. And we can also figure out the ball's initial velocity for the y component. So Viy is equal to v sine theta. And all we have to do is plug in our values, and we find that Viy is equal to 21.2 meters per second. Now the x component and the y component of velocity are not always the same in projectile motion. That just happened here because we're dealing with a 45-degree angle. Now we are solving for delta x, and if we look at our x component, in order to solve for delta x, we would need to find delta t. And I know this because the x component is uniform motion, which means we can use the v is equal to delta x divided by delta t equation. We have v, we're solving for delta x, but we're missing delta t. So how do we get delta t? Well, we use the y component to solve for delta t and then plug that into our x component uniform motion equation. So let's do that. Working with our y component, we know we have to solve for delta t. Since we are missing the final velocity for the y component, the only kinematic equation that we should use is the yf is equal to yi plus viy delta t plus 1/2 ay delta t squared equation. And all we have to do is plug in our values and then simplify. And what we find is we have 0 meters is equal to 21.2 meters per second times delta t minus 4.9 meters per second squared times delta t squared. Now from here, the math might start getting a little confusing. But don't worry, all we have to do is common factor out delta t. Now I hope you can see that in order for this equation to equal 0 meters, there's two possible solutions. Either delta t is equal to 0 or 21.2 meters per second minus 4.9 meters per second squared times delta t is equal to 0. And since we know some time passed, we know delta t can't equal to 0. And so all we have to do is write 0 meters is equal to 21.2 meters per second minus 4.9 meters per second squared times delta t. And from there, all we have to do is rearrange for delta t. And what we find is that delta t is equal to 4.3 seconds. And with that, now we can move on to our x component. So we know that motion in our x component is uniform motion. That means we have to use our v is equal to delta x divided by delta t equation. And all we have to do is rearrange for delta x. Plug in our values, and we find that delta x is equal to 91.2 meters. Now we're done the first part of our question, so let's move on to the second part, which asks us, what is the ball's maximum height? In projectile motion, the maximum height occurs at the top of the parabola. And it's very important that you recognize that at the top, so at the maximum height, the velocity in the y component is equal to 0. And that's because the y component is moving with free fall motion. And we had learned in free fall motion, at the maximum height, the velocity is equal to 0. And now if we look at what we have in the y component, the initial velocity was 21.2 meters per second, the final velocity was 0 meters per second, the initial position was 0 meters, and because it's free fall, the acceleration was negative 9.8 meters per second squared. Now we need to solve for yf, the object's final position when it reaches the maximum height. You can also think of this as delta y since the initial position was just 0 meters. Based on this, we can use the Vf squared is equal to Vi squared plus 2a delta y equation, and all we have to do is rearrange for delta y and plug in our values, and what we find is that the ball's maximum height is 22.9 meters. And that's the end of our projectile motion question. I hope you learned how to use the kinematic equations and the different x and y components to solve a projectile motion question.